Here is another example of implicit differentiation. Again, equation involving x and y. X to the power 3 plus y to the power 3 equals 6xy. This equation represents y as a function of x. And the question is find the derivative of this function, dy over dx. Again, it can be written as just y prime. All of the examples of this sort look like this. Given an equation involving x and y, and this equation is not solved for y, so this equation represents y as a function of x. And since it is not solved for y, this is an implicitly given function. So we can put implicitly given function of x. And find the derivative of this function. Once again, the solution is standard, so we will do left-hand side derivative equals right-hand side derivative. Now, left-hand side derivative is this x cubed plus y cubed, and the right-hand side derivative is not a number, it is now 6xy. So again, let's calculate both derivatives carefully. So left-hand side in itself equals x cubed plus y cubed. So the derivative of that equals x cubed derivative is 3x squared plus means plus, and then y cubed derivative, again, since it involves y, we got to calculate derivative using that rule. We do derivative normal way and then multiply times y prime. So normal way means y cubed derivative is 3y squared, and then we multiply times y prime. So that's the left-hand side derivative. Now right-hand side alone is just 6xy. Right-hand side derivative is therefore, there is a product here, 6x times y, so we have to use the product rule. Again, derivative product rule means derivative of the first factor times the second plus the first times derivative of the second. 6x derivative is just 6. Now times y, the second factor, plus 6x times the derivative of the second factor, and that is just y prime. So here's what we got. We got left-hand side derivative equals right-hand side derivative. Therefore, 3x squared plus 3y squared y prime equals this, 6y plus 6x y prime. And now our job is to isolate y prime. One thing we can do, since we can see every coefficient is divisible by 3, so one thing we can do is just divide everything over 3. So that becomes x squared plus y squared y prime equals, and 6 becomes 2, so it's a 2y plus 2xy prime. And now, like before, we want to move all the y prime terms in one side of the equation to one side of the equation, and all the terms that have no y prime in them, move them to the other side of the equation, which means we want yx squared to the other side of the equation. We want to keep this one here, we want to keep this one here, and we want to move 2x y prime to the left hand side of the equation. So here's what we get. On the left hand side of the equation we get y squared y prime. And then this one goes here and it will become negative, so minus 2xy prime equals. On the right hand side of the equation we have 2y. And then x squared moves to the right hand side, so it becomes negative minus x squared. And now we can factor out y prime and isolate y prime in this equation. So to factor it out, we get y prime times, and here we have y squared minus 2x equals, and the right hand side we just keep as it is. And the last term, the last step we divide both sides over whatever factor is next to y prime. In order to isolate y prime, we divide both sides of the equation over y squared minus 2x. So it becomes 2y minus x squared divided y squared minus 2x. Again, the answer is a fraction. In fact, in problems like this, the answer will always be a fraction, because the last step of solution is to isolate y prime, and that means to divide both sides of the equation over the factor next to y prime. That means the answer should be a fraction like that.